In this question, we're asked to write the solubility constant expression for two different compounds, strontium carbonate and nickel 2 hydroxide. So in order to do that, what we need to realize is that SrCO3 as a solid will break up into solution. Strontium's a 2A metal, so we'll get Sr2 plus aqueous floating around in solution plus CO3 2 minus aqueous floating around in solution. Note that the stoichiometry here is all 1-to-1. There's one strontium and one carbonate, so we're good to go. The KSP, which is products over reactants, except for the reactant is a solid, so we ignore it, is equal to just the concentration of the products. In this case, Sr2 plus and CO3 2 minus. It wouldn't be a bad idea to review your polyatomic ions for this section, because many of these compounds will have polyatomic ions like carbonate or like hydroxide. Let's look here at the nickel hydroxide. Well, we're going to start off the same way. We have NaOH2 as a solid, and it's going to break up. However, we don't necessarily know the charge on nickel because it's a transition metal, but we do know the charge on the polyatomic ion hydroxide. So as I mentioned before, it is a good idea to review your polyatomic ions. So how are we going to figure out the charge on nickel? Well, we're going to use the charge on hydroxide. Note that the charge on this ionic compound and every other ionic compound is 0. That's the total charge. So if we do this as a math equation, the charge on nickel plus 2 times the minus 1, the charge on hydroxide, 2 because there's 2 of them, minus 1 because that's the charge on hydroxide, is equal to 0. Nickel minus 2 equals 0. Add 2 to both sides, and what we find is nickel equals plus 2. So what do we get? We get Ni2 plus aqueous plus OH minus aqueous, and because it's 2 hydroxides, we need a 2 here. The KSP is very similar. Again, we ignore the solid because it's not aqueous, and the KSP is equal to the concentration of Ni2, the 2 plus should be in here, Ni2 plus, concentration of OH minus, and because there's 2 of them, we square it. So we get the concentration Ni2 plus times the concentration of OH minus squared. So these are just 2 different examples of how you might write the KSP expression.